So today we're going to talk about studying learning on life. I'm going to explain a little bit about what on life means in a minute, but the idea is that we're going to look at how you find and study learning online, but in a situated way. So to understand learning with technology, the technologies must be located and the experience is bounded. And this has always been relatively easy to do. The technologies of learning have always been relatively easily located. It hasn't been that difficult to notice where the blackboard is, or if someone was using a personal computer, or any number of other technologies of learning that we could have found in classrooms or in other learning settings. But recently, things have gotten a little bit more complicated in terms of finding where the materials of learning take place and where they're located. So in the same way that the materials and the resources in learning experiences have been relatively easy to locate, learning experiences themselves with technologies have been relatively well bounded. It's possible, as we see in this picture here, to see that these two students are using a graphic calculator, they're using paper and pencil, they're using Cubalinks to work on math. And all of that within a relatively small area that's relatively easily bounded. Now, of course, there are more complex ways to look at the materiality of learning, but just in the most surface level, here we can see everything in front of us. But a few things have happened in the last few years that have really made this more complicated. And the big thing that's happened is network technology, and particularly mobile connectivity. Mobile connectivity has meant that we can have all kinds of very complex technologies involved in our learning experiences in all kinds of places. So in this picture, you see a child using a mobile phone, a smartphone, to take pictures of goats at a zoo. This is an example of a child who also looks up information on that mobile phone while they're at the zoo. So you can see the location of that learning technology is not quite so simply defined as just the mobile phone. In this case, they're reaching out to resources that are well beyond the space they're in. And we've had this discussion about classrooms for quite a while, where we talk about the classroom opening up to the world through digital technologies and networking, or the world coming into the classroom through these technologies. But with mobility, these kinds of experiences and this opening up comes with us in all the places we go. Another thing that's happened recently is so-called SaaS, or software as a service, and with that, device agnosticism. And that's the idea that a lot of the services that we use, the software that we use, doesn't care what we're using to access it. So it doesn't care if we're using a computer or a tablet or a mobile phone. It doesn't care what kind of computer we have. We access it through a similar browser on all of these different devices. So the hardware has actually become less important. So in that sense, it's even harder to locate the technologies of learning, because the thing we focused on previously, the hardware, is no longer the most important part of the equation in terms of the technology. The hardware is just simply a glass slab with a chip in it that's connected to servers that are delivering services and platforms that we use. In this example, you see SmartTick, which is an online learning platform. And you'll see this in most classrooms today, that the kids are using online learning platforms that are browser-based, or using technologies that are largely browser-based. They don't need to install software on the devices anymore. It all runs in the cloud, so to speak. And this brings us to a kind of one of the words I used in the title for this, on life. And this comes from a philosopher called Luciano Floridi, who in 2007 minted this idea of breaking down this online-offline divide. What happens online in real space as somehow being different from what happens, or what happens online in virtual space somehow being different from what happens offline in real space. Floridi's idea of on life is that for many of us, we are online all the time. Many surveys ask how much people use the internet, or how often people access the internet. And for many of us, that doesn't make a lot of sense anymore, because the internet or the platforms and cloud-based software that we use is accessible to us through our mobile devices all the time, or through the laptops we use, or we're almost never unable to access it. It's always with us. So in that sense, we are on life rather than being online or offline at any given moment. And Charles S. in 2016, another philosopher of technology, outlined 4 points for what on life means. And he said the blurring distinction between reality and virtuality, the blurring distinctions between human nature and machine, reversing from scarcity to abundance when it comes to information, and shifting from the primacy of entities over interactions to the primacy of interactions over entities. And those last two are things we're going to talk about a little bit with regard to the methods of trying to study learning on life. Now, what's meant by reversing from scarcity to abundance when it comes to information is that we've gone from a situation where information is quite precious. We've gone from a situation where we had the Library of Alexandria being the holder of the known world's knowledge to a certain extent for that part of the world, accessible to very few legitimate people, to the democratization of knowledge through things like the printing press and the mass media, but still the need to go to a library, look up information in a card catalog, attend courses. We've gone to a situation where information is extremely accessible to many, many people without having to work that hard to get access to it. And the issue is no longer access to the information, but making meaning of it. And we are at a point where information is in abundance. We have a problem dealing with the amount of information and sorting the amount of information that's available to us rather than finding information. Shifting from the primacy of entities over interactions to the primacy of interactions over entities goes hand in hand with this. Much of what we do in the world is converted into data and information, and much of what we do in terms of producing data is formed through our interactions. And in that sense, our interactions become prime rather than ourselves as entities. So the entity of the object of us or the information is not as important in this information landscape as the interactions that take place. So as the technologies and practices of learning shift, so do the objects of research on learning, and they have to. We have no other choice. If we want to understand learning, we have to follow them through whatever material and technological shifts take place. And one of the major shifts that's been happening recently is what's known as datafication. And Victor Meyer-Schoenberger and Kenneth Cukier describe it as taking all aspects of life and turning them into data. And you can sort of understand this. Many of the software as a service platforms that we use today are focused almost entirely on centralizing the activities we do, the interactions we have, and extracting data from them. Many of the services we use are free for us to use and monetize our interactions, our activities, by producing data from them. So they centralize as many of our practices as they can in order to produce as much data as possible, and therefore develop as much insight on us as consumers as possible. And datafication in an educational or a learning context gives rise to both educational data mining and learning analytics, which are two fields that have developed quite strongly in the last 5 years or so. Educational data mining is the idea that we can extract meaning in terms of understanding learning from all this data that people produce in the digital platforms that we use. And learning analytics is the way that we make sense of that data to a certain extent, or the attempts to make sense of that data in an automated fashion. So many learning management systems like Canvas, for instance, include learning analytics features, which are often quite simple based on the amount that students engage with a particular video or file, or how often they retake a quiz or something like that. But all of this data produces actionable analytics. The kind of classic version would be exams, a national exam or a standardized exam that produces data that can then be used to judge the quality of schooling or the performance of students is an absolutely classic version of datafication in schools. But how data is produced and interpreted shapes conceptions of what it is to know. What data is available to us and how we are able to interpret it, to a certain extent, shapes what it actually means to know something. And this example in the picture here is from the Yale Chalkboard Rebellion of 1830. Up until 1830, the mathematics courses at Yale University didn't have blackboards at the front of the rooms. And up until that point, students were only responsible for delivering the answer to problems. They wrote at their desks on notebooks, and when they were asked to produce knowledge, they only produced answers. With the advent of the blackboard at the front of the lecture room, students could be called upon to show their work, to show how they'd arrived at answers. And many of the students at Yale in those first years felt that this was so threatening and didn't want to have their thinking interrogated in that way, that they actually rebelled. And the university expelled entire years of mathematics students because they refused to show their work, something that we now consider to be completely normal in a mathematics context. But you can see how the change in the material conditions for codifying the thinking processes and the learning taking place changed the conditions for what it meant to mean, what it meant to know that mathematics. It was no longer enough to know what the answer was. You also had to show how you got there. So in the same way, the kind of data we can extract through mining from different learning processes changes what we actually consider knowing of something to be, because we're able to gain different insights into the learning process. Another shift that's occurred is automation. And this kind of goes hand in hand with learning analytics. And automation, as John McCarthy described it, is that every aspect of learning or any other feature of intelligence can be, in principle, so precisely described that a machine can be made to simulate it. And this is from 1956. And the example in the background there in the picture is the workings of one of the original teaching machines that B.F. Skinner created, this one from 1958. And the idea with these machines was that you could program them with sets of questions, usually mathematical questions, but it could be any other kind of form of symbolic notation, so spelling or grammar or something like that. And students would input an answer, usually through a form of multiple choice, and then they would turn the handle, and the mechanism in the machine would be able to determine whether their answer matched the right answer or not. So they could do rapid iterations of simple questions and get direct feedback, an automated way of assessing their performance. But while this is a very old idea, the idea of automating assessments of learning, advances like artificial intelligence and particular forms of machine learning are making it possible for us to do that kind of assessment in a much more nuanced fashion than simply providing a yes or no, you got it right or you didn't get it right answer. And so we're moving away from this kind of programmed learning that you saw in these Skinnerian teaching machines, where learning is in programmed steps, to what can be described as structured adaptation, where the machine itself can adapt to the learning progress and make changes for individual students. And with data mining that can take account of natural language, also understand human language, We're moving away from a kind of content agnosticism where these Skinnerian teaching machines didn't really know anything about the content of the work the students were doing. They only knew whether an answer was right or wrong, not what the answer consisted of. Now, with natural language processing, it's possible for the machine learning to actually understand something about the content that it's working with. And so intelligent tutoring is kind of the flagship of how that works, if you want to see it in practice. But most AI ed or artificial intelligence for education processes actually automate administrative aspects of learning experiences. So while we might think that automation has changed a lot in terms of the actual assessment or guidance of students or tutoring of students in some way, or learners of any kind, most of the applications of artificial intelligence and of adaptive machine learning systems in learning contexts or educational contexts is actually much more related to administrative features, such as group formation, like dividing up of resources, scheduling, that kind of stuff. The third big technological shift that we've seen in the last few years is very much related to what I talked about with software as a service and cloud-based computing, and that's platformization. And Anne Hellman described this process in 2015 as platforms provide a technological framework for others to build on, geared toward connecting to and thriving on other websites, apps, and their data. At the same time, readying external data for their own databases is central to the economic model. So you see the kind of classic archetypal example here is Facebook, where Facebook starts off as a system for finding people and communicating with people on college campuses, a kind of like digital yearbook with communication features added to it. Over time, they open up the platform. So they make it possible for other people to add features, to post advertising on them that they can sell, to add Facebook games, to add different kinds of content on there. Google is the same way with Google Classroom, for instance, in schools, where they provide a framework with Gmail and Docs and all these features of their cloud that allow, for instance, textbook publishers to bring their content into the platform. So the largest textbook publisher in the world, Pearson, has an agreement with Google where you can basically, a teacher can basically, given the right contracts and agreements, bring in any of their content directly into Google Classroom. And this means that platforms such as Facebook or Google's platform or many of the other platforms that are out there, they function in a way that because they want to extract data from human activity, they open themselves up to bringing in partner applications and third-party features so that they can centralize themselves more and more within our practices and produce more and more data of us as part of their economic model. So you can say that what Jonas Anderson Schwartz described in 2017 as platform logics take place. So discrete applications are assembled on platforms with network effects. So what was previously perhaps a series of discrete software programs that you put on your computer to do different things, or in the classroom you had to do different things, is now assembled into a platform, sharing data with each other, and then producing that network effect of that shared data. There's a shift from technology in the classroom to classrooms in technology. So what you could have seen before as a classroom with, or a computer lab in the case of the picture in the background there, which is a classroom with a bunch of computers in it that has specific software in it. Now the central location for activity in many ways is that digital platform, and the classroom is attached to it. Because a platform like SchoolSoft or Canvas or Google Classroom manages to capture so much of the administrative and instructional activity and even social activity of what goes on in that classroom, it really forms a central place for itself. And for researchers, that gives us a bit of a problem, because as I've kind of talked about before, we end up struggling to locate that technology in the classroom or in the learning experience. Even worse if it's not a classroom, if we're looking at learning in more informal spaces. Because the platforms themselves are built up of many, many different services, and they're not always visible to us. So in this picture, you can see me looking under the surface when I use Canvas. And I can see that I'm actually communicating data with government servers, with Google that hosts on their cloud a lot of Canvases, activity with Amazon, who through their Amazon Web Services cloud has servers that host aspects, with Facebook, with a company called Akamai that hosts images that are shown on the web. And all these other little servers there are things like Permutive and DoubleClick. They're advertising platforms. Cloudflare is a security platform in a sense. Imperva and Fastly are analytics platforms, customer analytics platforms that share data about our activity between companies. So you can see that while there might be a single interface for me as a user accessing it on my phone or on my tablet, or for a teacher projecting it onto the whiteboard in the classroom, what's behind the scenes in terms of making data and using data and making sense of that activity is much more complex. And so this brings us to the problem of bounding platform experiences, bounding these any kind of learning experiences that are taking place with technologies that are in some way online, which, as I've talked about, are many, many activities now. Most of our life is so-called on life. This picture in the background here is a network graph of the resources that a group of teachers posted into a Facebook group discussing teaching over a 3-year period. So these are the resources they used as part of their learning as professional development in that group to discuss. And you can see the interconnections between these services and the way they fit together, with the colored ones being new media, you could say, and the gray ones, gray nodes, being more traditional Swedish language media. And just that complexity shows that to try to understand all the resources being used by a group of people as they try to learn something online is complicated, because each of those resources is located within a platform infrastructure, which is complicated unto itself. And all of these kind of resources and locations can lead in different directions. So the whole problem with these kind of online technologies is that they're pervasive, they're difficult to locate, and we have to find some way of unraveling enough of what's going on to make sense of it when we're trying to understand learning processes.